sorry about that. Al Cheswick, president of Krell Technologies. We're based in Neptune City, New Jersey. And what we do is we design and we manufacture photonic processing equipment. We can pretty much sum up what we do in kind of 3 words. We shape, polish, and inspect photonic components and fiber optic devices. Basically, kind of like the nitty-gritty part of the optics business, because what we're doing is really grinding material. So it's not like the sexiest thing like quantum computing or photon entanglement. It's like basic polishing and inspection of items. So what I'm going to do is really quickly give an overview of the applications that we address and the design challenges of the equipment to address the proper processing of different materials. First thing was connector polishing. Since first fibers were put in telecommunication network, there was always a need to join fibers and to have low loss and low reflectance joints, basically. So what we developed were connectors, and over the years there have been many different style connectors for this type of purpose, dozens of them actually. So when you're choosing a piece of processing equipment, you have to find one that is adaptable to all these different types of components, and they change all the time. Every year there's a new type of component that comes out. And since they're connectors and they're commercially available, there's issues of intermediability between other vendors. So industry standards have been developed, such as Telcordia and IEEE and mil specs, that any equipment that you develop, the product that comes out of it complies with the specifications and the requirements of those standards. And also in connector polishing, automation is key too, because you want to have low-level technicians being able to operate the equipment properly in production lines. And over the years, fiber has gone from telecom and datacom into many other applications that we've discussed already, including medical, sensing, laboratory. And with this, there's been developments in different types of probes and devices, endoscopes, catheters, different types of OCT probes, in sensing, vibration, structural sensing, fiber optic gyroscopes. All these are usually customized devices, unlike the connectors, that are specific to one manufacturer. Hence, any type of polishing equipment that you develop has to be adaptable and customized for those in particular purposes. And with that customization often comes intensive process development from project to project. And not all connectors not all bare fibers are connectorized. In many situations, you want to polish the bare fiber itself. In this case, you can see we're doing an example of a 125 micron fiber, and we're able to put various facets on it. And depending upon the shape, basically the shape of the end of the tip of the fiber gives you the ability to manipulate the light. And here in these situations, the challenge is basically with processing equipment is the wide variety of types of fibers that are available nowadays. It's not just standard telecom 125 micron fiber. Now you have PM fiber, you have photonic crystal fibers, you have sapphire fibers, and you also have a wide range of dimensions. All these have to be supported by adapters in these machines, and also taking into consideration the delicate nature of the fibers so that they do not break during the processing. The newest application we've been involved with over the last 5 or 6 years is photonic integrated circuits, or PICs, which, as most of you know, are basically chips that have waveguides embedded in them. These have represented new processing demands where material removal has to be controlled, length control is critical, and you have to be able to monitor their process very closely and make measurements on all these. What we've done with our equipment, we've developed a system called Nova, which is what our all-in-one solution that addresses all these applications and the considerations that have to be applied. So we have interchangeable fixtures for either connector polishing, bare fiber polishing, PIC polishing, probe any type of adapters. We use micron-level positioning for length control. We have it automated with a standard tablet and familiar Android interface for easy operation. We have manual programmable modes. Manual modes are used to develop processes, and those parameters then can be transferred to program modes. And with Nova, you're now polishing blind. We have vision systems that allow you to monitor the polishing process in real time and also inspect the quality of the specimens that are being polished while they're still in the machine, making it basically a work cell approach. We've been in business for over 30 years. We've had a proven track record of making high quality machines and unique machines. And we also have a very extensive database of processing. So when equipment is purchased from us, you're not just getting a machine, you're also getting knowledge support from many years. Any questions?